Okay, so today we're going to do Excel, and this relates to your very first lab that you're doing on your own. So I wanted to give you a little tutorial as to how to work Excel and enter in the values that you need. So the first thing I want to talk about is a little bit on significant figures. A lot of folks are still rusty with them or still struggling with getting them. And so you look at something like this calculation where we have our final and initial volumes that were recorded from the burette. And you'll say, oh, this one has 3, so therefore my final volume, my total volume, can only have 3. But remember, addition and subtraction is the number after the decimal. So these guys all have 2 after, all have 2 after. So this answer here is not going to become 3. It's going to be the difference of this and this with no more than 2 after the decimal. So let's see how to do that. We start with the equal sign because you're telling Excel to do math. And the final volume that we registered was the 18.33. So that cell number is C5, and I want to subtract the initial volume, which is B5. So instead of typing it out, let me try this. Let me just click on it, boom, enter. Now I've set up how our Excel is going to calculate that volume. I can have it do it for an entire set of cells. So in this particular example, we only have 3, so let's just make it do it for 3. So what I did is I took my cursor, ran it over the box until I got this small plus sign, left click and drag it down. Boom. Now notice this doesn't have enough sig figs, so let's go ahead and add that in so we don't make a mistake on that. So now it's going to do it, and if I needed to do 4 or 5, I can keep adding in and go in here and be like insert cell, insert cell. I've had a really bad day in the lab and I'm crying because I wore goggles for too long. And then I can just come over here and drag this down so I can just automatically, I just enter in my values and it's automatically calculated. But let's just say life went well and we didn't need this because we just did awesome. But you're going to see it kind of wasn't that way. So in the first video I showed you how to come up with the mole-to-mole ratio. If you don't remember how to do that, please do see that before you proceed any further. But from that video we figured out that there was 6 to 1. So 6 moles of sodium thiosulfate to 1 mole of this. But this is just a molarity calculation, and by just a molarity calculation, that might bring hives or a little strike of fear into some folks. I know that some of you still struggle with molarity. We'll deal with that on another video or come to my office hours. It's an important concept to make sure that you're comfortable with before this quarter progresses too far. All right, that said, I'm not going to go into the concept here. But we have the molarity of our KiO3, so that's 0.01000 moles of KiO3 in 1,000 milliliters of KiO3. I used 25 milliliters of the KiO3, so if I multiply this volume times the molarity in milliliters, I get moles. So in Excel, I'm not going to write out all my units. I'm going to suggest that you do that on paper ahead of time so you know exactly what numbers you want. And this is going to become B2, cool, selected that, divided by 1,000, that's my 1,000 milliliters, times E2. So that is my conversion. It has 4 sig figs, which is good, 4 here, life is good. Now let's go to moles of this. Like I said with the other video, we figured out that it's a 6 to 1. So if you write it out to look at your dimensional analysis, you'll see that it just becomes the KiO3 times 6. So F5 times 6. Bam. That's done. So no matter what, we know to hit neutralization, to get our equilibrium to its endpoint, then we have to have this molar ratio. So this amount of moles isn't changing. What's changing is whether or not we're accurately predicting what our endpoint is. So that's what we're going to get into here. So now our molarity, remember, is the moles in 1,000 milliliters. We have these moles in these milliliters, but that's not the definition of molarity, so we need to do the conversion from milliliter to liter to get that done. So equal sign, and we have, I'm going to do my parentheses because I like to make sure that Excel is doing what I want it to do. This guy, or moles, and in our 15.54 milliliters. Now to convert that, it's multiplied by 1,000. And if you write that out, you'll see that is indeed the case. Now, the one thing I didn't do is, let's see what happens if I drag this down, because I have those 3 titrations, right? Oh, something didn't work. Well, the reason it didn't work, if you look, Excel is automatically going down to the next cell and to the next cell. We want G5 always. So let's come back here, and the way we fix that, a dollar sign in front of the G says stick with that column, which is fine, that's what we want. But we want it to stick with G5, so a dollar sign in front of the 5 says only G5. Hit enter. Now let's try this again. Let's drag it back down. And we'll see that it accurately correctly calculates our molarity. So cool, we have that part done. Our average takes advantage of the built-in functions from Excel. And I keep saying Excel, but you can use LibreOffice. Any of them have these built-in functions. The functionality is darn near identical. So to find the function, I just start typing. I want average, AV, and there is average. I want the average of my molarities. So I left click and drug down and just left my finger there until I got to the bottom and hit enter. And I'm giving up the ghost too soon. There we go. Standard deviation, same thing, built-in function, so ST, and we want standard deviation S. And same thing, selecting the values here. So I'm left click and then hold and just drag straight down. And then hit enter. So that's our standard deviation. Now, standard deviation parts per 1,000, what we want to do is take the standard deviation and divide it by the average, multiply that by 1,000. So equals actually let's just do this, U divided by U times 1,000. Done. Oh, that's not pretty. I'm going to show you why that's not pretty in a second. This one's a little bit different because we're taking experimental. So this is saying that we're giving you this value and you want to compare it to your experimental value that you determine, which would be the average. So we're going to take J2, and we want parentheses here. So J2 minus L, actually, we'll just collect it, and then divided by J2, and then multiplied by 1,000. Okay. And that shouldn't be surprising that it's a low number, because before I accidentally gave up the ghost on this one, you saw that this rounded up to the 0.10. So let's see why that is. This is, our standard deviation starts in the thousands. Wherever the standard deviation starts is where your average, your reported value, ends. It says this is where we're in doubt. We're approximating here. So if I'm approximating here, then this number reflects that that's where the approximation begins. It cannot be any more precise than that. So I kind of intentionally chose these values because it tends to freak students out when they see there's the 7 there, which means it's going to round the 9, which means it's going to round the 9, which means, oh my gosh, I have a value where I didn't used to have one. It's okay. So you can see I've been using these buttons up here. This increases the decimal. This decreases the decimal. So if I click there, so let's see, how many do I have? I have 1, 2, 3, 4, but we're not really going off that. Remember, we're looking at in the thousandths place. So 1, 2, 3 is where I should be. Boom. So common error here is you get down to this point and you say it's 0. And then you lose points and you don't understand why. Do not use approximated values here. Use the whole thing. Your grades are calculated using the whole value. We take your experimental input and figure out what the true values are, not what you approximate, because you get tired of punching in all the numbers on your calculator. So word to the wise there. And that's really one of the biggest advantages of this. So like I said, this 35, let's see how much that cost you in points. Pull this over here. So 35 over 13 minus 1. You did good on your accuracy by chance. I mean, we're all over the place. You look at this and you're 1 milliliter off here, and a half from here and almost a half from here. So you got lucky. The average came out to what is correct, but this is really, in a scientific application, horrible. So what you do to fix that is you just do more titrations, and that's how I'd set this up before. And if you do this ahead of time and punch in your numbers, you can see what you're looking at over here. And you also get a very good feel for, do you need to do more? Are you spreading things out so you don't know? Because truth be told, what you're going to see most of the time is this number, that 35. And so then what a lot of students will do then is they'll say, well, this one and this one is close, so my next titration, I'm going to just keep going until about 15 so I can make this a smaller number. Yeah, that's called cheating, and the cheating penalties apply to lab as well. So don't do that. What you want to do is just start over like you don't know anything and see where that value comes in. So say I came in close to the 14.5. Then do it again. And if the third time you come in close to either your 14.5 or your 15s, then I would do one more to confirm that that is indeed the actual pattern, that I'm either closer to 14.5 or closer to my 15s. And then I would use that data on what you turn in, and you just make a note of it in your notebook, your lab notebook, that these are your outliers, that you've fine-tuned it and you know that these are correct, or whatever the case may be. And so there's my pitch. Please, please, please do not use Excel as a data sheet where you just put in numbers and you crunch the numbers by hand. A lot of forlorn students in the first couple labs, when they get everything back, when they see their grades, it's a very sad moment. So very easily overcomable. It just takes a little of discomfort working through learning how to enter things in here. So please, please, please do just come to office hours or ask questions. Happy to help you out. And if you have any questions, as always, let me know. Shoot me an email, and we'll see you in class.